This is Chapter 10, Problem 15. In this problem, we have a wheel that is allowed to have an angular acceleration of 3 radians per second squared. At some time interval of 4 seconds, we know that the wheel is going to turn through 120 radians. So the trick here is we don't know the initial angular velocity of the wheel, and we don't know the final angular velocity of the wheel. And what they're asking us to do is figure out how long has it been in motion at the start of this 4-second interval. So this would be like if somebody started running and they were accelerating, and then you just picked a random time period and said, okay, they traveled this distance. You don't really have a whole lot of information here. You don't have an initial velocity and you don't have a final velocity. So what we're going to do is we're going to set up a system of equations to solve this guy. The first equation I'm going to look at is our omega squared is equal to omega naught squared plus 2 alpha delta theta. So we know alpha, we know delta theta, but we don't know omega squared and we don't know omega naught squared. We don't know the initial angular velocity or the final angular velocity. I'm also going to bring in the equation omega is equal to omega naught plus alpha delta t. Notice I'm keeping it delta t because usually when we say t, we're meaning from the start of the motion. But this isn't the start of motion. This is actually some 4-second interval into the motion. So now I'm going to get a little math crazy here. I'm going to substitute in the second equation into the first equation. So you're going to get omega naught plus alpha delta t, and that quantity is squared, and that's equal to omega naught squared plus 2 alpha delta theta. Okay, all I did was substitute in the second equation into the first equation. Squaring the left-hand side of the equation gives us omega naught squared plus 2 omega naught alpha delta t plus alpha delta t squared is equal to omega naught squared plus 2 alpha delta theta. This looks like a mess, but luckily a lot of stuff is going to cancel out. So the omega naught squareds are going to cancel out. That makes life a little bit easier. So now we have 2 omega naught alpha delta t is equal to 2 alpha delta theta minus alpha delta t squared. All I did was move the alpha delta t squared to the right hand side of the equation, so now I have everything that has omega naught on the left hand side. Now you can substitute in your numbers, so you're going to get something like 2 omega naught times 3 times 4 is equal to 2 times 3 times 120 minus 3 times 4, and that whole thing is squared. And what you'll get is you'll get omega naught is equal to 24 radians per second. Now that's the initial angular velocity at the start of the 4-second interval. And over that 4-second interval, just like the entire time period for the wheel, the angular acceleration is 3 radians per second squared. So now this omega naught, I'm going to transform this into omega, because they tell you that the wheel spins up from rest. So we want to find the time period that it takes the wheel to spin from rest, omega naught equal to 0, to a final angular velocity of 24 radians per second. That'll give us the time interval that the wheel was spinning before we started measuring 4 seconds. So now using our omega is equal to omega naught plus alpha t, we're now going to have 24 is equal to 0 plus 3 times t, and we get a time interval of 8 seconds.